All right. So let us begin with RDS. Right. So RDS is another service from AWS, right? And what does this RDS stand for? It stands for the Relational Database Service, right? So I hope you guys know what is a relational database, right? Basically, we are talking about SQL type based databases, right? Where you have tables, records, and all that stuff, right? And then you have other types also, right? Which are non-relational or NoSQL databases. For that, we have other services. So the relational database service from AWS is for these type of databases. That is for the relational DBMS systems, right? So under the RDS service, they have 6 DB engines which are supported. That is MySQL, right? MariaDB, Postgres, Oracle, and Microsoft SQL Server, right? So all these you can use anywhere, right? So you can download these and you can deploy it anywhere, right? You can download and deploy them anywhere, whether it is on the cloud or on premises, right? All that stuff, right? And apart from this, right, they have one more called Amazon's Aurora, or we simply call it Aurora, right? So a total of 6 uh, SQL-based DB engines are supported under RDS. And what is Aurora? Aurora is a DB engine from AWS, right? So basically, it is available in 2 types. One is MySQL or Postgres, right? So Aurora itself is based on either one of these things. You have 2 flavors under Aurora. It is Amazon's implementation of MySQL and Postgres. So if you are using some applications, right, with MySQL or Postgres, you can migrate it to Aurora, right? You don't have to make any DB level changes or application changes or anything. You can just take a backup and restore or something like that and do it. So Aurora is compatible with either MySQL or Postgres. Okay, and Aurora can be used only on AWS RDS. You cannot download and install Aurora like you would do for the other DB engines. Okay, it is not available for download and using it. Okay, so it is purely available only on the RDS platform on Amazon. It is MySQL or Postgres available in 2 editions, right? It is how AWS have implemented it because these are open source, right? So AWS has taken them and they have they have developed their own DB engine, which they call enterprise class, right? Enterprise grade DB, but with a lower cost, compared to Oracle and Microsoft SQL Server, right? Lower cost, which is the main feature. I mean, main the marketing of Aurora, right? They market it as a enterprise grade DB, right, with a lower cost. Okay. Okay. I hope you guys are. I mean, I just put some presentation. I mean, comparison, right? You can just go through this, or I'll share the another document also, right? We have something like this. Let us say, right? If you want to compare, because we have a separate service for the non-relational DB engines, right? So in your the relational database, you have tables, rows, columns, right? A schema, right? And you scale them vertically, right? You have queries, joins, all these things, right? And examples are like RDS, right? Postgres, IBM DB2, all these are the relational DBMS systems, right? Whereas the non-relational things, they have their own structure, right? How you access them, right? All those things. So you might have heard of MongoDB, right? All these things, right? All these are, they are not relational. For that, AWS has a different service. Okay. For that, so here data can be stored as key value pairs or as a document, right, or as a graph, right? It is not just tables or columns and records, not those type of things, right? It has a different structure and it has a slightly different use case, right? And another thing that probably you want to keep in mind is something like this, right? So a DB, right? I told you you can deploy it anywhere you want, right? So you can take the DB software and install it on a EC2 instance or on your server, right? So so don't worry about the last four, right? We'll come to that after we finished RDS, right? So if you take these DB engines, right? MySQL, MariaDB, right? All these things you can download and deploy them anywhere on the cloud. Means, say for example, you can download MySQL and deploy it on a EC2 instance. So it is like a traditional, what do you say, DB server, where you install the OS, you manage the server, you install the DB engine, right? You do its configuration, all that stuff, and you have a lot of control over it, right? When you do something like this, right? You have full control over the database and the server itself, right? Whereas in RDS, right? So what is the main feature of RDS is you don't need to install or manage any server, right? It is provided as a service. So what you do is you simply go and say, I want a MySQL DB, some version 5.7 something, and you specify some basic configuration, right? You specify how much CPU RAM you want, right, for your server, but you actually don't log into any server, right? It is fully managed by AWS. That is, you don't have access to the OS. You can't log into the OS like you do to a traditional DB server. You don't have OS level access, and also at the DB level, maybe you don't have the root permission or certain permissions you might not have, like a full-fledged DB server, right? Right. So it is provided as a service, right? It is provided as a service, and then you have other DB engines, right, which we will see, like NoSQL, data warehousing service. These are all, what do you say, other services which are also related to data or the databases from AWS, right? So again, to use RDS, you have to know your database, whatever database you are using, right? You have to be a DBA or a developer in order to use it, right? Any one of these, you can use RDS, right? Any one of these, you can use RDS, because Aurora is also based on either MySQL or Postgres. It is the same thing. So your same tools, same, what you say, applications, everything are same. It is just where the DB is hosted or how it is hosted is different. So your existing tools, software, right? The way you use the DB, all those remain the same. There is no change with that, right? If you know how to use MySQL, the same principle, same tools, SQL developer or whatever tools you're using to connect to the DB or manage the DB, all those remain the same. There is no change in them. It is just how RDS is hosted, right? It is provided. It is like database as a service, right? Where you don't have access to the OS, or you don't have to install the OS or the DB engine. That is the one of the main things. Okay. So I'll just quickly open the console and show you, right? And then we will come back to the other you say topics in RDS. So here you go to RDS, right? Managed Relational Database Service. Right. So everywhere you see here, they will try to push Aurora. Right. Aurora is available as MySQL or Postgres. Right. So what you simply do is you say create database. Right. So I will just use the old console. The new one I am still not very comfortable. Okay. So it is still more or less the same. Right. Just the options will be switched here and there. Right. So I don't want to struggle with the new DB console in the class. You can explore that, right? The steps are pretty much the same. So here, this is just a high level flow, right? So you choose what DB engine you want. Say you want MySQL, you choose MySQL, right? And you have to remember that with RDS, there might be some limitations. That is, you might not get all the features, or certain features might not be compatible with RDS, especially if you are using Microsoft SQL Server or Oracle, because they are proprietary what do you say, software, right? So certain features of Microsoft SQL Server may not work on RDS. Same thing for Oracle. So that your DBA or the database developer has to go through the documentation to see if RDS will fit their requirements, compatibility issues, the version related issues, feature related issues, right? Those type of things. Okay. So you can choose MySQL, MariaDB, whatever DB engine you want, right? So let us say I want MySQL, right? And it just gives some basic features of what is possible, right? You can have a database up to 64 TB, right? All this stuff will come back to this, right? And then the next step, you create the DB. So here in RDS, what you are creating is this. You have to remember, right? In RDS, you are not creating a database as such. You are creating a DB instance, because in some places it will say create database, right? That is misleading, right? You are actually creating a database instance. So think of it as a EC2 instance with database already installed, with the database engine installed. So what you are creating is a DB instance or a DB server. Think of it like that, right? So inside of a particular engine, right? So you can create a DB instance of MySQL, right? So here you have the DB instance. So this DB instance can have multiple databases. It is not one database, right? It can have multiple databases of MySQL. It cannot have mix, right? So when you are creating a database instance, you specify the DB engine which you want. So you get an instance. Instance means what? It is just like your EC2 instance. You specify how much CPU RAM. That is, here we call it the DB instance type, just like EC2 instance type. Here it will be something like db.m4.large, right? So it will have some CPU, RAM, and storage. You can add as much as you want. Storage comes from EBS, right? You can use either GP2 or you can use the provisioned IOPS. You can't use the other types, right? So similar to your EC2 instance, here also you have the DB instance types and storage. Okay. So, but you cannot log into this OS. That you have to remember, right? You cannot log into this instance at the OS level. You can only log into the MySQL DB engine, right? So you don't have access to the OS layer. So remember, what you are creating is a DB instance of a particular DB engine, right? Inside that you can have one or more databases, right? Okay, so here you have some basic templates, right? So say for example, I'm choosing MySQL because they keep pushing Aurora, right? Even though I chose MySQL in the previous step, again they are saying choose Aurora as MySQL, use MySQL under Aurora. So I said no, I don't want Aurora, because Aurora we'll see in a separate class. Okay, so let us say I'm choosing MySQL, right? And then here is where you configure the DB instance. So it is not the DB as such, it is actually the instance, right? So you specified the DB engine, right? You can specify the license model, for example, like Oracle or Microsoft SQL Server, right? They are paid, they are not open source. So there you will have bring your own license, right? Or whatever edition you want accordingly, right? And then you have the DB engine version, right? So what version you want, you can choose. Suppose the version you want is not here, means it is not here, right? You want a specific version and it is not there over here, then if you want it, then you can create a EC2 instance. You download that database software, install it, and use it like a traditional database. Right? So only the versions shown here are available on RDS. Right? If you are okay with a version, the next version or the closest version, you can go ahead and use. Again, if you want to read about this, it is given here, right? The version number or whatever, right? So if it is available, and again it will have some, I told you, issues, limitations, right, with about features, right? So you want to take a look at those documentation, right? And then here is where you choose the DB instance class or the instance type, right? It's just like your EC2 instances, but with a DB prefixed, right? There's some CPU and RAM, right, for your database server. You're creating a database server which you can't log into. Basically, that's what you're doing, right? And then we will see what is multi-AZ deployment, all that stuff we will see, right? You specify how much storage you want, right? All this kind of stuff, right? You give a unique name for your DB instance, right? Right? These are some of the basic steps. You go next and you create it, right? And you get a DB instance, right? You get a DB instance, and you can log into the DB instance using your, what do you say, your existing tools, right? Whether you are using SQL Workbench or you are using what do you say, SSMS for Microsoft SQL Server or whatever, those tools remains the same. There are no special tools to connect to the database or any such thing, right? Whatever tools you are using, you can continue to use them, right? So which database are you guys working on? I think you said you are from the database background, right?
Yeah, I have worked on multiple databases. Right now, working on Hadoop only.
Oh, big data. Okay, that is different. Okay, okay. So the same tools you
But
can use, right? So
yeah,
there are no different or special tools to connect to RDS. All your existing tools, software, the way you use it, all those remain the same. Okay, okay. And then you create your database instance and you connect to it using your existing tools, and you do your development or database administration work over here, right? So it is like a as it is provided as a service. So here you don't what do you say, you don't manage the OS, that is OS management. You don't have to do it, right? OS management, updates, all these things we are not going to do. We don't have access to do, basically, right? And RDS provides you with multiple features like backups, right? So it handles backups, but you can specify certain options, basically, right? So RDS handles backups for you, backups and restore, right? You can restore to a point in time, right? Say you want to go back. Now it is 8:47 a.m., right? Say you want to go back to 7:45. You can go back. You can restore back to a point in time down to a, the granularity is a second, down to a second. Right. Okay, so say you want to go back to 7:45 and 0 1 second, you can go back, right? You can uh, do that on RDS. A lot of the backup related stuff is managed by RDS itself, right? And if you want high availability, right, they have something called a multi-AZ deployment model. We'll talk about that, right? High availability or DR, right? You have a multi-AZ deployment model, right? If you want to improve the performance, that is, you want to scale the read performance, right? You can use something called a read replica, right? These are some of the things that you can, right? But you can't, as such, log into the server that is at the OS level. You only interact with the the DB instance. That is, you log into the DB engine using your existing tool, whether it is command line or GUI. Those tools, those things, they remain the same. Okay. Okay. So what I'll do is first we'll create the DB engine and then we will talk about the features, because this RDS will take a few minutes to create. It is not like as fast as EC2 instance. It will take a few minutes for it to be created. So we will create it, then we will talk about the features while it is being created, right? So how do you create it? So let us say we need a MySQL database. I will show you with that, but you can use whatever DB engine you want. The steps are more or less the same, right? So you say create database, right? Again, it is misleading. You are creating a DB engine. You are not creating one database, right? That DB engine can have as many databases as you want, right? Right. So let us say you want MySQL or you want Oracle or whatever, right? You choose, right, which edition you want, right? I want Oracle Standard Edition, right? Say something like this, right? And then you can choose something like production, right? And you can say bring your own license or whatever the version you have, all these kind of stuff, right? The steps are more or less the same, whether you're doing MySQL or Oracle or whatever, right? I'm going to go with MySQL. So in the free tier, right? So RDS is there under free tier, right? RDS is available under free tier, but only these five are available under free tier, right? Aurora is not there on in the free tier, even though it is AWS's own database. It is not available under free tier, right? These five are available under free tier. What you get is T2 micro DB instance, that is db.t2 micro for just like your EC2 instance, 750 hours per month. Any of the DB engines. Again, you can't use enterprise edition, those type of things. I think in SQL, Microsoft SQL Server, you can use the Express edition or something like that. Same thing in Oracle, I think standard edition or something, right? All these are anyway open source, but the DB instance type has to be t2.micro, right? 750 hours per month and some amount of storage you get. You can check that in the free tier how much it is, but it is available under free tier for you to practice, right? But I'm not going to use T2 micro because it will be very slow to create, right? So I will use a slightly bigger instance type so that it is a little faster, right? So I'm going to choose MySQL, right? And then we go to the next step. So here you just have a template kind of thing, right? We are not going to Aurora. Aurora will see in a separate class. So if you choose production, certain values are pre-filled for you or automatically chosen. This is just like a template or a wizard. Okay, I'm going to choose production so that we can see all the options, right? Right. So here you go and choose what is the DB engine you want, right? Say for example, I want 5.6 or 5.7 something, right? And then you choose the DB instance class. Why is this not coming? Yeah. Okay. So you choose the DB instance class, right? How much CPU and RAM you want for your database server, right? So you will increase it as you would for any normal database server, right? So if your usage is more, you can do the monitoring and you can change the instance type like how you do for a EC2 instance. Okay, so I'm going to create something like T3 dot medium. Okay, so that it will be a little faster than T2 micro. But if you want to stick to the free tier, stick to TV dot T2 dot micro. Right? If you want to stay on the free tier, you can use that. Right? And then we will talk about multi-AZ deployment. Right? We'll come back to that. Right? For high availability. For now, I am not going to choose it. Right? And remember, your RDS, your database instance is created inside your VPC. Right? Your DB instance is going to be inside your, what do you say, the VPC which you create. Just like your EC2 instance, it is going to be somewhere in one of the, what do you say, the subnet. Usually, databases we put in the private subnet because usually people from outside don't access the database. Right? Only your applications need to access the database directly. From outside, usually people don't access. So usually the database servers are placed in the private subnet. But remember, RDS is inside your VPC, inside a subnet. You can control which subnets to use using something called a subnet group. Okay. So remember, RDS is there inside your VPC. Okay. RDS is there inside your VPC. Right? And then here you have the storage, right? So mostly for databases, especially in production, people use provisioned IOPS because for a database, the storage performance is also very important, not just RAM, right? Usually for databases, right, it is RAM and storage which is usually more important. That is high speed storage with high IOPS because a database usually it does a lot of small reads and writes. Right? It does a lot of small reads and writes, so you generally want to use provisioned IOPS for database workloads, right? But you can use either general purpose or provisioned IOPS depending upon your actual workload. But from exam point of view or whatever, if you see a question talking about databases and what type of storage to use, the appropriate answer would be provisioned IOPS. Okay.
So yeah, Siddharth, since you told this database resides inside VPC, right? So ideally it should be subnet, right?
Yeah, inside a subnet, just like your EC2 instance. Where is your EC2
Yeah,
instance? It's inside the subnet. Same thing your database instance also.
yeah. Okay.
Right? Which subnet it is going to reside that you can control. Right? Right? So I'm just using the general purpose storage, right, of 20 GB. Okay, because we are not going to put any lot of data or anything, just the bare minimum I'm using. Right? Okay, and now they have added a feature called storage auto scaling. Earlier it was available only for Aurora. Now it is available for certain other DB engines also. What is storage auto scaling? As you as you run out of space, it increases your storage automatically. Right? You don't have to manually scale the storage. If you want, you can. If you uncheck this, you manage the. I mean, if you're out of space, you can increase the storage. Right? Or you can use storage auto scaling, and it is going to increase the storage. Right? Up to a maximum you can specify. Right? It is not going to go infinitely. You can say scale up to 1000 GB. You can go up to 16 TB. Right? So I'm not going to use storage auto scaling. We'll just leave that. Right? And don't worry about this estimated monthly cost. What is this estimated monthly cost? It is assuming that you are using it, what do you say, every day for 1 month continuously. That is 750 hours. So we are not going to do that. We are just going to practice for a couple of hours and remove it. So your cost will be very low, especially if you are using anything other than T2 micro. Okay, especially if you are using anything other than T2 micro. Okay, and then here you give some information, that is your database instance identifier, right? So it is like a unique name for your DB instance for this database server, right? I'll say we'll just call it my DB instance itself, right? MySQL, right? And you can give a master username and a master password, right? So again here there might be some limitation, right? You cannot use what do you say, something like admin or root or certain things you can't use, right? Even though here it says it's an alphanumeric string, right? It is the login for your, it is the master what do you say, credentials, right? Like the root credentials, but you can't use certain names. I'm not really sure. I think something like root or admin it might not allow you to use. Here it might let you specify, but while creating you will get an error. Okay, so here you can give, sorry, right, a username, right? So I will use this same thing as the username. Okay, what happened? It is more than 16 characters, right? Or I'll just, let us just put it as AWS user itself. What is it? Right? Some master username and some master password you need to provide. Right? So which is going to be your credentials to log into this DB instance. Then afterwards you can create additional credentials inside the database for other users to connect to it. Right? You can configure the permissions for other users. You can create other users and they can connect to your database. Right? The next step is where you are going to specify which VPC to place your DB instance. Right? So we are choosing our we have only one VPC in this region. So I'm specifying that, and then here you have the subnet group, right? So here it is like you specify which subnet group to use, then a specific subnet, right? In EC2 what you do, you say put in A, B or C or something like that, right? Here you specify a group. Now say for example how this works is, say for example in your VPC, sorry, say you have a VPC, right? And then you have some subnets, right? Like this you have some subnets, right? So maybe these are your public subnets, these are your private subnets, let us say, right? We know already subnet will be in some availability zone, whatever, right? So what you do in RDS is, right, you can create something called a subnet group. So in this subnet group you can say, let us call this subnet 1 2 3 4 5. In this subnet group I can say 3 and 4. That is, this subnet group contains subnet 3 and subnet 4. Right? I will call this subnet group A, let us say. So while launching my DB instance, I will say place it in subnet group A. So it will place it in either one of these subnets. Right? Which is how you control which subnet to place it. Okay? You can't say place in this or this, right? You need to create something called a subnet group. Right? The group is just one or more subnets under it, right? So if you say this subnet group A is 3 4 5, then it can it will use these three subnets are indirectly the availability zones, right? The default subnet group is, I mean, it can use anything, right? All the subnets in your default VPC it can use, right? In this case, in our VPC, all the subnets are public. Okay, and here you have another option, right, called publicly accessible, right? That is, if you want your devices or servers outside your VPC to be able to access this DB instance, then you have to make it publicly accessible. Basically, it will get a public IP, right? If you want your EC2 instances or devices outside the VPC to connect to this DB instance, suppose you want to connect straight away from on-premises or from another service provider or something, from a public connection, right? You're not doing a VPC peering or something like that, maybe from another AWS account, from outside your VPC, right? Then you need to enable public access, right? Okay. Okay, and then again, availability zone you can specify, right? It will choose the subnet from that availability zone, right? Or you can leave it to no preference. It will choose any one of those availability zones where your subnets are present. And then you have a security group similar to your AC2 instance, right? So you can specify from where connections are allowed, from where connections are not allowed, all that stuff. It is just like your regular security group, right? It's your VPC security group, right? And then here you have certain options like database name. So if you want, you can create an empty database to start off with, or right, or there will not be any database, right? You're creating a database server. If you want, you can create a database here itself, or afterwards you can log in and create. That is up to you. So I will just put like demo, some empty database it is going to create, right? Right, and then these are other things, certain things that you need to explore as a DBA, right? So I'm not going to go into what is parameter group, what is option group, right? The port is, you know, right? Each database engine has its default port on which, right, it runs. So you can use the default ports, or you can change the port numbers like 1433, 3306, whatever the DB engine you are using, right? And then you have something called the parameter group and option group, right? So this is purely at the database level for the database specialty exams. So we are not going to go into these things, right? So you want to look at these things for certain specific features or options or configuration related to your databases, right? And then you have this IAM DB authentication. Again, we will talk about IAM in a separate class, right? So if you want to manage your database through the AWS users, that is, like I said, you can create users, right, called demo or whatever like this, right? Additional users, right? So if you want your users to access the database using their existing AWS credentials, you can do that, or you can manage your DB authentication using your database level users and passwords. That is up to you, right? And then we have an option called encryption, similar to your EBS volumes or whatever. If you want to encrypt your DB instance, that is basically your storage, you can enable encryption, right? You can specify the default key, or you can upload your own encryption key and encrypt your database instance. Okay, so we are not going to do that, right? And then you have backups. We'll talk about what are these backups. Okay, so basically in RDS you have two types of backups, right? Right, you have automated backups, right? You have automated backups, so it is like a full backup, right? Full backup. There is AWS takes one full backup every day, right? And then it takes the backups of the transactional logs, I think, every 5 minutes. This is handled by AWS, right? AWS takes, I mean, you can configure it, right? It's called automated backups. There is one full backup and transactional log backups every few minutes. So what this allows you to do is you can restore to a point in time, down to a second, right? And automated backups, it can be between 0 to 35 days. That is the retention period. How long to retain your automated backups. 0 means it is disable automated backups. This might come in the exam. Right? How to disable automated backups? It is by changing the retention period to 0. From 1 to 35 means automated backup is enabled. Right? If it is 0, it means it is disabled. If the retention period is 0, it means automated backups is disabled. Okay. So the default is 7 days. If you here you can't see disable. Right? If you set it to 0, it means the automated backups are not taken, which means you can't restore to a point in time because there is no backup, right? So you can specify like 1 day or something like that, right? Whatever you want between 1 to 35. So these are called automated backups, what you specify over here, right? So apart from that, you can take manual backups, or they are called DB snapshots, similar to your EBS snapshots, right? DB snapshots are manual backups. You can keep it for as long as you want, right? Keep it for as long as you want. Okay. So DB snapshot, again, remember what it is backing up is not one database, right? These backups are backing up your entire DB instance. The DB instance may have one database or two database or three databases. This automated backup or DB snapshot is taking a backup of this entire thing. It is not single databases you are managing. It is the entire instance that is backed up. Right? It is the entire instance like which is going to be backed up. Okay, and then here you have the backup window. So you can specify when you want the backup to happen, when you want the full backup to happen, because usually when a backup happens, it may impact the IO. Right? It may impact the IO. So usually you want to schedule your backup during off-peak hours. Right? Usually you want to schedule your backup during off-peak hours, which is where you have a backup window. Right? And then you have some monitoring stuff. We'll come back to this later. I'm going to disable all these things, right? Enhanced monitoring, all these things, right? And you have these logs also, right? For your database, slow query log, error log, audit log. You can push these logs to CloudWatch logs. We saw what is CloudWatch logs, right? For VPC logs and all that stuff, right? So if you want, you can push these to CloudWatch logs for monitoring. Again, all this is database level. We are not going to go to these things. You can publish these things to CloudWatch logs for monitoring purposes, right? And then you have another option called maintenance. These are the things that you need to know from architect level, or I mean, if you are not a DBA, if you are a DBA, you want to work on core RDS, then all the features you should keep an eye on. But otherwise, in general, these are the features that you need to know, right? So what is maintenance or maintenance window, right? So under maintenance, right, you have an option called enable auto minor version upgrade, right? So if there is a new minor version of the DB engine, do you want it to be automatically upgraded, right? Because you don't install any software or as such over here, right? So these are done by AWS. So do you want it to happen or no, right? If you don't want, you select disable auto minor version upgrade. And what is maintenance window? So the maintenance window is when these type of changes or patches will be applied, right? Suppose say you are modifying you're creating a DB instance. Say now I created T3 medium or something, right? With 20 GB of storage. Now let us say I want to modify this. I want to go to T3 large and I want to go to 50 GB. So you can modify your DB instance. You can say modify, right? And you specify the new values and then you click apply. So what happens is these changes are not applied immediately, because for certain changes, the DB instance might have to reboot, right? Or it might impact the performance. So usually that any changes that you make, they will usually be applied in the next maintenance window, right? So you can specify your maintenance window also, right? If you say no preference, it will choose a random maintenance windows, right? So maintenance window is the period in which you want pending modifications or patches applied to your DB instance by RDS, right? Whether it is upgrading minor version or applying certain patches, or you make some modifications to your DB engines, those type of things, right? And then the last setting is the delete protection, similar to your EC2 instance. If you enable that, accidentally it prevents it prevents accidental removal of your DB instance, right? Just like your EC2 domination protection. And then you say create database, right? You are actually creating a DB instance, not a database, right? See, your DB instance is being created. How long it will take, it depends upon the configuration and the instance type that you specify. It will take 3 to 4 minutes at least for it to be ready, right? So again, this console is a little, okay. So here you see your DB instance is created, right? So it is a DB instance of this DB engine of this type. Status is creating, right? So if I click on this, you can see its properties and its configuration over here, basically, right? What is your DB instance, what engine version, what is the database you just created, right? What is the instance class, all this stuff you have, whatever we just specified, all these you can modify, right? Except the uh, certain values you may not be able to modify, but most of them you can change, right? And here you can come back to the logs and events, and you can check the events, right? It is just being created, so it will take a few minutes, right? So here, how do you connect to the database, right? So here, if you see, it would have created a security group. So if I go to my VPC or my security groups over here, right, it is going to be in your VPC only, right? Security groups, right? So here, if you see, it would have created a database security group, RDS launch wizard security group. It would have opened the port, because I said publicly accessible. It would have opened this port for my IP by default, right? So here you can control from where people are allowed to access your database instance, just like your EC2 instance access, right? You open the port number for the source IP, or right, from where people are allowed to connect to the database, right? It is controlled by using this security, right? And how do you actually connect? You don't use IP address, even though it has an IP address, right? You are given a DNS name, that is the endpoint, like a URL. So you use that to connect to your database instance. You don't use a IP address, okay? So it will take a few minutes for this to show up, right? This DB instance is still being created, right? We just have to wait for it to be available. So here is the default subnet group. So it can use all these things. That's what is happening in the background, right? And you have our security group. Sorry, I clicked on it, right? The same thing, right? This is the security group which it is using. Okay, we'll wait for that to be created. Yeah, another thing is when we talk about backups, right? So you are given a space equal to the amount of storage you provision for backups. Suppose you are creating a DB instance with 100 GB, right? You are given 100 GB of storage for backup for free, right? So remember, AWS, they charge you for everything, right? So backups also, they occupy some space. So you are given space equal to the amount of storage you provision for your backups for free. It is included, right? You take additional backups, you pay more, a little more for the TB snapshot storage, right? So that is another thing that you want. And as with other things, right? So these backups or these snapshot are stored in S3 in the backend, right? These TB snapshots or automated backups are actually stored in S3 in the backend, right? Just wait for this to be created. Right. So here you see it has provided you with the endpoint, right? It has provided you with the endpoint. What is the endpoint? It is uh, the connection string, you can say, right? How you connect to the database, right? How you connect to the database. So here is the connection string, and here is the port. You know the username and password. So let me just copy this. Here is the connection string. We know the port, right? What is the username? I think we said AWS user, right? And we gave the password. So so you connect to the database using this information, whether you are using the command line or the GUI tools or whatever. Those tools remain the same, right? So here you can just go here. So whenever you create a DB instance, right, it is going to create and automatically take one full backup, right? So it is part of the process. You are creating a DB instance, right? It creates it and it takes a backup. So first, it's first full backup, okay? And you can monitor it over here, right? You have certain metrics over here. If you want, you can use your own monitoring tool also, right? You can use your own monitoring tool. All this is for, what do you say, TVS and those guys, right? You want to monitor your CPU utilization, free space, right? All those things, right? Right. Queue depth, the latency, throughput, right? And what do you say, if you are using replication, replica lag, those type of things you need to keep an eye on, right? Right, you can see your free storage space over here, right? For EC2 you can't see the storage space, but for RDS you can see what is your free storage space, right? And all these other things, right? How much memory is being used, and based on all those things you can change the instance type later on, right? So we will try to connect to this DB instance, right? So I'm going to use MySQL Workbench, right? So you create a new connection, right? You give the connection some name, right? Demo RDS, I'm just going to call it. The host name, you don't have an IP address. You are given the host name as such, that is your DNS name for this RDS. So the DNS name is going to look like your, what do you say, database instance identifier, right? The first part, right? Followed by this random characters that AWS generates, followed by the region .rds.amazonaws.com. That is the format, and then you give the username and password. Right, the other things, default schema, all those things you can choose if you want to. Right, so when you connect to this, provided you have opened the port, it will ask you for the password. Right, you give the password, you are logged into your database server. right? You see, you can see that database which we just created, the initial database, right? So here you can go ahead, you can do your development or database administration or whatever you want, right? So say simply I want to go and say create some table, right? Okay, so this is from here onwards, it is your own database server, right? So here you can have multiple databases, all that stuff. You can manage the users, right? All those things is your usual database stuff. Okay, so let us see whether this has finished creating. Yeah, the status is available. So it has finished doing whatever it needs to do and it has created this, right? So currently this DB instance is in US East 1B. So it is in a single availability zone, similar to your EC2 instance, right? It is in US East 1B. Okay, there is only one copy of the DB instance, okay, which is single AZ deployment, right? Which is called single AZ deployment. We'll come to multi AZ deployment also. Okay, we'll come back to multi AZ deployments. Okay. So the next feature that we are going to see is called something called the read replicas. Right? You have something called so now what we have created is a single DB instance. Right? Let us call it the master. Right? So it is there in a single availability zone. So if this availability zone has any problem, your database will be down. Okay. So the first feature we will see is called read replica. Or just RR I call it. Okay. So what is a read replica? Right? So it is going to be a replica of your master database. Right? It is a asynchronous replication. Right? So what is this read replica used for? Right? So usually what happens on the database, you are going to either do the writes or reads. That is, your application is going to either read or going to write the data on the database. Right? So what is this read replica is, it lets you scale the read performance. So read replica is not for high availability. So remember, now whatever we are talking about is not about Aurora. Aurora has slightly different features. Aurora we'll see in a separate class. Right? So what is a read replica? Right? It is a asynchronous replica of your primary or master. Right? The master handles all the reads and writes, but your replica, your read replica can handle only reads. Right? Sorry, reads. Okay? Read replica can handle reads. That is, say if your application is going to do a lot of reads, then you can spread out the read loads. Or say for example, you have another application which is a reporting application. Right? Reporting applications, they usually only need to read data. They don't need to do any writes. So you can create a read replica and you can point your reporting application to the read replica. Instead of all your applications hitting the master for everything, right? You can spread out the load by creating something called a read replica, which handles the reads. Right? It is a asynchronous replica of your primary or the master. All the read writes uh, happen on the master, but you can spread out the read loads. If you have multiple applications which need to access your database for reads, then you can point your applications, reporting applications, those type of things to use the read replica. Okay, so read replica is also a DB instance, right? All these are DB instances. It is not a single database, right? Each of it is a DB instance. So this entire thing is replicated over here, right? And you can point your other applications to this. So this is a DB instance. Each of it is a DB instance. It is just that it is in sync, or it is a replica of the primary. That is, there is a continuous asynchronous replication which happens, which is managed by AWS. You don't need to configure this replication and all that stuff. That is handled by AWS. What type of replication, mirroring, whatever, those type of things are handled by AWS, but it is asynchronous replication for read replicas, right? And the read replicas will be able to handle only the read traffic. You cannot do any writes to the read replica. Okay? And read replica is not for high availability. This you have to remember from exam point of view. Read replica is not for high availability. Read replica is only to scale performance. That is the read performance, to distribute your read traffic. It is not for TRR, high availability. Because if the primary fails, your read replica will not become the primary. It will not be promoted to the primary automatically, right? So read replica is not for high availability RDR. It is just to scale your read performances. Okay, so they can be in different availability zones also, right? You can put your master in 1A, you can put a replica in 1B and 1C, or they can even be cross region. They can even be cross region, right? You can have your primary in US East, right? And you can create your replica, for example, in EU West or something, right? You can do that also, but the replication lag will be slightly higher. That is, your read replicas will be eventually consistent, right? Because the replication has to happen, right? The uh, if it's in a different region, it takes more time. More time means maybe in seconds. It's not in hours. If it is in hours, there is some problem, right? So it is in a few seconds usually, right? So there will be a replica lag, right? So if this application it tries to get the data from this, right? If the lag is a bit higher, then it might get some old data, right? Because it is asynchronous replication. That is, first the data is written over here, then it is replicated over here, right? So there will be a couple of seconds of lag that you have to keep in mind, right? And your applications, they they connect to this because each of it is a DB instance. Each of it will have a connection string. That is the endpoint, like how we saw over here, right? So each of your the read replicas, they will have a endpoint. So you connect to it using its endpoint. Okay. So how do you create a read replica? We will do that now. Okay. So we have a DB instance. We have connected to it, right? We have connected to our DB instance called demo RDS. It has a database. We created a table, right? So I'm going to create a read replica of this DB instance. So how do you do it? You go to actions and you say create read replica. So replica is again you're creating a DB instance, the same steps. It can be same instance type, different instance type, all those things. Storage, all these things you can specify which region you want to use, right? Basically all the same settings, right? Basically all the same settings. If you want, you can modify it, right? You can modify it. What is the replica source? It is going to replicate from my DB instance MySQL, which is going to be the source of its replication. For this DB instance, you can give, again, you need to give a DB instance identifier, right? And then the other usual options, right? Whether you want monitoring, you want to export the logs, right? The maintenance, auto miner version, all those things, and you say create read replica, right? What I didn't specify, DB instance identifier, I didn't specify, okay, right? I will call this my DB instance MySQL RR read replica, and I'm going to say create replica. So now what it is doing, it is going to create another DB instance, right? So if I come back here, you see it is going to create a second DB instance called my DB instance, whatever, I forgot to put M, okay, MySQL RR, right? So it is going to be a replica. So it is modifying both. So this is done by RDS in the background. You don't do anything. You just specify what you want. It is going to modify and do that for you, right? So it is actually creating another DB instance, right? So it will have its own endpoint, all this stuff, right? It will have its own endpoint, its own monitoring, right? Its own configuration. It is only that it is in sync with the source, right? It has its own DB instance, ID, all that stuff, right? So again, this is going to take a few minutes for it to be created, right? For certain changes, your DB instance might need to reboot. For certain things, it doesn't need to reboot, right? Okay, so just give me a minute, guys. I'll be back. Okay, sorry. Yeah, I'm back. Okay. So we'll see whether the read replica has been created. Right here, it is creating. Still, it's in the process of being created. And meanwhile, you can use your, what do you say, your primary, your master, right? So say I'm creating another table, right? So we are connected to the primary or the master, right? So how do you connect to the read replica? So it has its own connection string, right? So here you have your read replica, right? Still it is in the process of being created, right? So once it is created, you will get its endpoint and you can connect to the read replica. That is, you can point your applications to the read replica. We just have to wait for it to be created. Okay, so we just wait for this to be created. Okay, so we'll check whether it has been created, right? Yeah, so it is available. So let me now try to connect to my read replica, right? Let me connect to my read replica. So it will have its own endpoint, right? The endpoint is again going to be a DB instance identifier followed by this, followed by the region, right? So you connect to this the same way, right? Using its own connection string. Sorry. Now I'm connected to the read replica. Right? So here is the read replica to which I am connected. You see it is going to be in sync with the primary or the master. Right? So here, for example, say I'm creating another table, right? Something like this. Right? On the primary, right? Now I go over here to my replica. Let us say I refresh. You see that it has replicated that table which I created over there. But here, if I try to go and do something on the read replica, right? I'm trying to, right? You see, it is not going to allow it because the read replica is in the read only state. So it can not do any, what do you say, inserts, updates, those type of things. It cannot do, right? It can only do the read queries basically, right? So this is the read replica. You can point your certain applications to this read replica. Okay. So read replica is used to scale the performance, that is the read performance. Okay. So the next thing that we are going to see is multi-AZ deployment, right? Multi-AZ deployments. And prior to we going to that, again in read replica, one more thing that you probably want to keep in mind is about the cost. Again, cost you have to pay for this second one because it is another DB instance. It is just in replica, right? You have to pay for this T3 medium, whatever it is. But if you are using it in a different availability zone or the region, right, then you have to pay for the data transfer cost also. So remember, AWS charges you for data transfer, right? So if you are going to do, if you are going to keep your replica in a different availability zone or a region, you need to pay for cross region or uh, data transfer across availability zones. That cost you have to pay. If it is in the same availability zone, then you don't need to pay for the data transfer because replication is what? It is data transfer, right? So if it is in the same availability zone, you don't need to pay for the cost. Okay. So we'll take a small break and then we'll continue, right? 15 minutes break we'll take. We'll catch up at 10 a.m. Okay.
Okay.
Right. So we have seen about the read replica, right? So basically, you're creating another DB instance which is going to be in asynchronous replication with the primary, right? So here are a few more things, right? I told you about the backups, right? So here you have your backups. If you go to snapshots, right, you will see manual and the system. What is the system? It is like your automated backups, right? Same thing over here, right? So manual is what snapshots you take, right? Manual are manual snapshots for which are taken for certain things like creating a read replica, right? Those type of things. So here you see I have a snapshot which I took earlier, right? It is there for some other DB instance, so I should have removed it. I didn't remove it. So let us go and delete this snapshot. We don't want this. Okay. So for this current DB instance, we don't have any manual snapshot. We just have a couple of these system snapshots which were taken first when it was created. Second time, I think it created for replication or whatever, right? So these are automated backups. Okay. Okay. So here you can choose this and you can say create DB instance. That is, to restore snapshot means what is going to happen? It is going to create a new DB instance. Okay. From that snapshot, from that date and time, you can create a new DB instance. right? So you want to give a database for your developer another copy or whatever, right? Same thing. The restore snapshot means again it is going to create another DB instance, its own standalone instance. So you don't want to restore a snapshot, but you want to do it for your existing database, right? So for say example, uh, there was some problem on this database, right? We created this around half an hour ago or so, right? So say there was some problem, you want to go back a few minutes or few hours or few days or whatever, you can do that, right? You can go back and say restore to point in time. So what is this restore to point in time going to do is it is going to ask you uh, how, what is the date and time you want to go back to, right? It is going to ask you what is the date and time that you want to go back to, right? The last restorable time will usually be 4 to 5 minutes prior to the current time, right? Current date is 10:09, so the last restorable is 10:05, right? You can do it to 6, 7, 8, 9 also, but you have to wait for a few more minutes. It is not that you can't restore to like 10:08:56, you can, but the latest time will be around 4 to 5 minutes back from the current time. Or you can say custom, right? You can say I want to restore to October 11th because we just created this database, right? I want to restore it to something like 10 a.m. 01 seconds or something like that. And what is this restore going to do? It is not going to overwrite your existing database or database instance. It is creating another new DB instance, right? Which will have data from this date and time. So it is not a single database which is being restored or rolled back. That is, your existing database instance is not modified, right? It is going to create a new DB instance with this date and time backup, right? Again, the same steps to create your database instance, right? You can give same instance class, whatever, all the other things, right? So it does not modify your existing database. So if you want to take only a specific database backup, or you want to restore a specific database, for that there are other steps that you should explore. For that you need to use S3, right? You can create a, you can execute a query to take a backup to S3, right? You can specify the source DB and the destination as your S3 bucket, right? And you can back up a specific DB if you want to. But in RDS, it only backs up your entire DB instance. It doesn't back up a single database, or it does not do a restore of a single database. If you want to do that, you have to do that using your own queries, as a separate process, right? So here, when you do a restore, it is restoring all the databases in that DB instance back to this date and time on a new DB instance, right? So here you have our primary, right? It has one database, let us say, what we created, right? So it is going to restore this entire thing on a new database instance from the date and time that you specify. Okay, so it is not going to modify your existing database instance, right? This will continue to be there. You will get another DB instance, and you can, what do you say, replace it, or you can recover your data, or you can do whatever you want with the backup you have, right? So that's what is to do a restore in point in time, right? That is how you restore a backup, whether it is a manual backup or an automated snapshot. The process is the same, right? So when you're creating a DB instance from a snapshot, it is creating a DB instance with all the databases. If you are restoring to a point in time, it creates a new database instance with the old the date and time that you specify the data from that date and time. Okay, all this is about the 5 Aurora, slightly different options you have. Okay, so I will go ahead and remove this sorry, not remove. So what can you do with this read replica? We saw that it handles only the read traffic. It cannot handle the write traffic because it is only in the read only state, right? So apart from this, right, this read replica can be promoted to become a standalone database. It will automatically not fail over, but you can promote it, right, to become its own standalone database so that it accepts read and writes. Now, say for example, your developer wants a copy, so you can promote this replica and give it to him. You use it, right? You can do that. So how you do that? You can go to actions and you can say promote, right? When you promote the read replica, it becomes its own standalone database. So if it is its own standalone database, then it needs to have backups and all that stuff, right? So if you want, you can enable automated backups for that and the backup window and all that stuff, because now it is going to become its own database, right? So here is just some recommendation. I mean, so if you're promoting this, you stop any transactions, because if replication is going on, then you might not have all the transactions committed and all that stuff, because we are not doing anything here anyway. All our transactions are stopped, right? So it again takes a few minutes, right? So what happens? It stops the replication and it reboots this. What do you say? So that it becomes its own standalone DB instance. So once you promote it, you cannot go back. It cannot become a read replica again, right? So I'm saying promote read replica, right? So it will do whatever is required to modify this again, right? It will be in the modifying state, and in a few minutes, it will become. This will no longer be a replica, right? This will no longer be a replica. And another thing is, in order for you to use a RAID replica, automated backups must be enabled on the DB instance. Otherwise, you cannot create a RAID replica. Right? Sometimes in the exam, you might get the question, right? I have this primary. If I try to create a RAID replica from this, right, and it is not working because probably you have not enabled automated backups for this, right? So in order for you to be able to create a RAID replica, you should have automated backups enabled for your DB instance, right? And how many RAID replicas you can have? You can have up to 5 RAID replicas, right? You can have up to 5 RAID replicas for your primary. They can be in the same availability zone or different zone, but you are allowed a total of 5 RAID replicas, right? And RAID replicas, they don't do automatic failover, right? If you want the primary is down, then maybe you can promote your RAID replica to be its own master, but you have to update the connection string in your application, because your primary application will point to the master. It will have its own connection string. So if this fails, you can recover manually. It is not automated. So RAID replica is not for high availability, but you can use it like active passive, what do you say, manual failover. So you can promote one of your RAID replica to become its own DB instance, and then you can point your application to this by updating its connection string. Okay, which is what we are doing now. We are promoting the RAID replica. Right. So apart from that, we'll let the RAID replica see. Now it has become an instance. It is no longer in replica. It is rebooting. Okay. So apart from that, what are the other things you can do? Now I have my DB instance. So let us go into that. You can modify it. Right. I told you most of the options, right, which you specified while creation, those can be modified. You can change the DB engine version. Right. You can change the identifier or the master password. Right. You can change the instance type, you can add storage, you can modify the storage type, right? All these things you can do, right? Basically, whatever we specified while creating, those things you can modify, right? But when you modify something, say for example, now I am changing the storage, right? Say for example, storage, now I am running out of space, I am manually scaling the storage, I am making it 22 GB. Okay. Other changes also you can do. And then what you say? You say continue. Right? And it will show you the summary of the changes. Right? I'm just modifying the storage here. So the default is what? When you say modify DB instance, right? The default is these modifications are applied during the next maintenance window. Right? The next scheduled maintenance window it will be applied. That is the default. So no, you want to apply it immediately, then you say immediately, because certain changes might what do you say, need a reboot or might require a downtime. So you have to be careful, right? So usually the maintenance, I mean, these changes you want to apply during the maintenance window or during off-peak hours. Or no, you want immediately, you can choose immediately, right? So pending modifications might require downtime, right? So that is up to you, right? So when I say modify, so if there are any other pending what do you say, maintenance, they will also be done. Suppose I say do this during the next maintenance window and I say modify, right? So it will say successfully modified, but it has not modified. Okay, it will say successfully modified, but here if you go to the DB instance, right, you see some pending notifications, pending modification. That is, it needs to do this. It will do it in the next maintenance window. Now again, if you go and modify and you make some change, say for example, let me change the instance height maybe. What should we do? Some small change I want to. Okay. So say for example, I'm changing the instance type from T3 medium to T3 large. Okay. And again I'm saying continue, and now I'm updating the instance type. Storage already we have specified. It is already recorded. It is going to do it next maintenance. Now I'm saying no, I want to do it immediately. So when I do this, the storage will also be updated, right? So any pending modifications will also be applied. What is my pending modification? That storage. We said do it during the next maintenance window, right? But now I made another change and said do immediately. So it will include those changes also, which are already pending. They will also be updated. Now if I say modify, right, it will go and the state will change to backing up, and because to change the instance type, it needs to reboot. Right, you see it has gone into modifying state, and my read replica is in the backing up state because now it has been made into its own DB instance. So now if I go to the read replica, which is here, which earlier which didn't allow me to do any, what do you say, creates or updates, right? So let us just go and right, it just disconnected because it rebooted. Right now I'm connected on the X read replica, right? So if I go here and say I'm going to create a table now, you see it is going to allow me to do it, right? Earlier it didn't allow me to do it because it was a read replica. Now it has been promoted to its own DB instance, so its connection string everything remains the same, but now it is its own standalone DB instance, right? It is its own standalone DB instance, right? So this is the read replica. I'm going to remove the read replica. I'm going to delete the read replica. And of course, I told you you can't log into the OS or whatever, but you can stop your DB instance or reboot your DB instance. Right? You can stop or reboot. Right? You can keep it stopped only for 7 days, if I remember correctly. Right? It is not like your EC2 instance which you can keep it stopped for as long as you like, because earlier, around a year or two ago, right, you could not stop your RDS instances. They had to keep running. So people again, they wanted some flexibility, because certain databases like development databases, they might not be using all the time. So to save money, they wanted a stop feature. So AWS has included a stop feature. So you can keep your DB instance stopped for up to 7 days, I think 6 or 7 days. If you don't start it, it will start up automatically, right? So RDS instance stop. Let us say, I think it is 7 days. Yeah, 7 days. In 2017, they have added this thing, right? So you can stop an instance for up to 7 days. After 7 days, it will be started automatically, right? Or you can reboot it, right? If you don't want, you delete it, right? And it will ask you, do you want to create one final snapshot? No, I don't want. Do you want to retain automatic backups? So the default is the automatic backups are are kept, right? So you don't want to retain anything, because we don't want to have anything. So I'm going to say, just clean up everything, right? I'm removing our old read replica, which became its own database, right? It's removing this, and our uh, this primary, right, my DB instance MySQL, it's in the modifying state, because I added a little storage and I changed the instance type also. So it is performing those changes. Okay, so again, it is going to take a few minutes for this to complete. So we'll just wait for this to be updated. So here you see now it has changed the instance type from T3 medium to T3 large, and probably storage also it has increased now, right? Storage has gone from 20 GB to 22 GB. It should go up, right? It is still in the modifying state, right? So another thing is sometimes this console might take a few minutes to update, right? Sometimes this console might take a few minutes to update, but the actual changes may have already been applied. Okay, actual changes may have already been applied, especially when you're using the multi-AZ deployment and those type of things, right? The old console takes a few minutes to update itself, but in the background, it would have already probably finished applying those changes. So let me close this read replica. Let us go back to our master and see whether it is available. Right? Yeah. Right. Okay. Yeah. So the master is up. Right. So simply the storage is being modified properly. Right. So probably that will take a few minutes, but it is ready, more or less ready. Okay. So the next thing that we are going to see is multi-AZ deployment. What is multi-AZ? Okay. Multi-AZ deployments. Right. So as the name says, multi-AZ is using two availability zones. So normally when you create a RDS instance, right, your primary, right, your master or primary, right. I mean, when we are using RDS, we usually, what do you say, we denote it like uh, one of it as the master and one of it as the secondary, right? So without multi-AZ, what happens? You have only the single one, that is the master, right? It is in a single availability zone. You can have your read replicas in different availabilities. But what is multi-AZ is, right? RDS itself maintains a secondary copy in a different availability zone, right? So this is going to be like standby, right? So this is going to be like a standby, right, in a different availability zone, right? And you get only a single DNS endpoint. You get only one DNS endpoint. You don't get two DNS endpoints. And you have your applications or whatever the users, right? They connect to this endpoint. This endpoint will always point to whatever is the master currently, right? So this secondary is in synchronous replication. It is not in asynchronous replication. It is in synchronous replication, right? In multi-AZ, but it is standby. That is, you can't connect to the secondary, right? If RDS it detects a problem with this, right, either the instance problem, because at the back end it is actually a EC2 instance and all that stuff, right? Suppose there is some networking problem, availability zone problem, instance problem, right? So if it detects a problem, right, it will automatically do the switchover, right? It will automatically do the switchover, and your DNS endpoint will always point to whatever is the current master. So your in your applications you don't need to make any change. Your application, your users, they always use the same endpoint. This endpoint is fixed, right? This endpoint is fixed. So they connect to this. So this endpoint will point to whichever is the the current master, right? So in case of problems with availability zone, the network, right, the instance, right, storage problems, right, these type of things, it does automatic failover, automatic failover to the secondary. So this secondary or whatever is the secondary is standby, right? It is not actively used. It is just in synchronous replication, and it kicks in whenever a problem is identified with the master, right? And you have only a single endpoint which always points to the current master. Okay, so here multi-AZ is used for DR, right? It is used for DR. It is not to improve performance because there is only one master on which all the read writes happen. Secondary is simply what do you say, a backup, standby, right? It is the standby. Okay, you can't have another application pointing to this. You can't, right? So read replica is sorry, multi-AZ is for DR, right? And read replica is for scaling the performance. It is not the other way around. Okay, so what you can do if you want both DR and performance, you can combine both. You can combine both. You can have a read replica, right? You can create a read replica over here. So this read replica will be with asynchronous replication with this master, whichever is the master. Basically this endpoint. It will be in sync with this endpoint, whichever this endpoint is pointing, right? So now you can point your reporting application or some other applications which need to do the reads to this read replica, and your main application which needs to do the read writes to this endpoint, because your read replica will have its own endpoint, right? It will be in sync with this. So you can combine both multi-AZ and what do you say, read replicas. So currently multi-AZ is only 2 availability zones. It is not across the regions yet for these 5 DB engines that we are talking about, right? So your multi-AZ, as the name says, it is multi-AZ. It is not multi-region. Within US East, for example, we are using now, within US East 1, we have 6 availability zones. So it uses 2 availability zones to achieve this multi-AZ deployment. How to do this? Simply while creating your DB instance or while modifying, you specify it as multi-AZ. It sets up the replication and it is going to do it in the background. You don't need to manually go and configure certain replication and all that stuff, right? So here we'll come back here. So we have our DB instance over here, right? So it is optimizing its storage still, right? It's we give a small amount of storage, so probably it's taking some more time. So we'll see whether we can upgrade this to multi-AZ, right? Storage is being optimized. It's already increased. So here again you can go to modify, right? And you can choose multi-AZ, right? You can choose the modification multi-AZ, or while creating itself you can choose multi-AZ, right? By launching itself you can say multi-AZ, or here also you can make it multi-AZ afterwards also, right? So it creates a standby instance in a different availability zone to provide you with data redundancy and all these things, right? So it has certain other advantages also, not just for failover.
So that just a doubt here. So since you told we can have this in a different availability zones, right? We can have it in the same also, right?
No, the name itself is multi-AZ, right? You can't have it in same.
Okay, okay,
Multi-AZ means different availability zone. You can't have it in the same availability.
okay. Okay.
Okay. So here again we are making a modification. We are saying now deploy this as multi-AZ. Earlier it was single AZ. So again, it might need a reboot because it needs to take a backup and again deploy the stand-up, configure the standby, and do that configuration, right? So all this it does by itself. You don't have to take backup, restore, set replication, all that stuff. So it does what is required. So basically, if you need to deploy it as from a standby to multi-AZ, right, from a single AZ to multi-AZ deployment, what it happens in the background is it stops your DB instance. It takes a backup. Using that backup, it creates a second instance. All that stuff it does by itself. So it takes a few more minutes, right? So I'm saying apply the changes. So again now it needs to do that. It will take a few more minutes for this to happen, right? It's going to take a few more minutes. Or while creating itself, you can say create database. You can choose the multi-AZ deployment. It will do that, right? So the smaller the instance type, it takes more time for it to happen. Okay? So we just have to wait, no other option because we are having a live class, right? So right now you see it is modifying, right? So what is it doing? You can check the events, right? You can go to the events and keep an eye on it, right? What is happening? The latest events are there over here, right? So it did the storage stuff and all that stuff. Now it is applying modifications to convert it into a multi-AZ DB, right? So it will do that. It is going to take a few minutes. We'll just pause and we'll come back when it finishes. Yeah. So here you see the current DB instance is in 1B. So just keep an eye on this, right? The current DB instance is in a single availability zone in 1B, right? And here if you see it is currently not multi-AZ. So when this completes, you will see this multi-AZ and you will see a secondary zone specified over here. Right, it is still modifying, right? Yeah, I think it should be. Yeah, now here you see it's saying multi-AZS secondary zone. It will come up in this console. It is going to take some time to reflect, but I think it has completed its conversion, right? That's probably sorry. Right, so it has finished the conversion, right? It is just doing the miscellaneous monitoring stuff, right? The primary is in 1A, secondary probably might primary is in 1B, secondary is probably in 1C or 1A or something. It will show up here. It's just going to take a few minutes. Right, but if you go to your DB instances here, you will not see two instances. Okay, here it will show you only one instance, which is in a multi-AZ deployment. Okay, multi-AZ will say yes. So here you will not see two DB instance, but actually there are two DB instance. The second one is standby. So think of it as you paid 2 times the cost because you have to pay for the standby also because it is always there, right? Right, it has become available, but this console is not updating. Right, if you see, the endpoint remains the same. The endpoint, there is no change. There is only a single endpoint, which is what I think we have already connected to, right? Which is what we have already connected to. So we are already connected to the endpoint. So this endpoint remains the same, right? So currently whatever it shows you here is the primary. The secondary is shown over here, right? The secondary zone will pop up over here in some time. Probably in the new console it is faster. Old console has this problem. Not sure if they fixed it in the new update. Right, I'm just waiting for it to show up so that you can see the difference. It's taking too long to show. And another thing here is you have the reserved instances for DB also, similar to what we saw yesterday for EC2 instances, right? So you can purchase the reserved DB instance to optimize for cost, right? So similar to your EC2 instance, suppose you're using DB instances are usually used for longer periods of time, right? You're not simply going to remove your database instance or whatever, right? So if you want, you're having a production database and you want to put it on RDS, you can save some money by purchasing a reserved instance for a for DB, that is an RDS array, right? You can choose the term over here, right? 1 year or 3 years, that is the default, right? Like I told you, and you can choose partial upfront, all upfront, or whatever, how many instances you want, and you can create a reservation, right? That is just to optimize your cost. Right. So here you see now it is showing up as 1C, right? So the secondary is in 1C, right? Secondary is just a hot standby, waiting. You can't connect to the secondary, right? What you connect is this. What is this currently pointing to? 1B, which is the current primary. Secondary is 1C. So how do you know whether it is going to fail over? I told you it will fail over when there is a problem. So we can't create a problem as such, right? So what you can do is AWS has given you an option where you can reboot with failover. Suppose you want to check whether your failover is working, you can do that. You don't have to wait until a problem occurs, right? Right. So you can do this reboot with failover. So now if you see, currently our primary is 1B, right? In this case, what we have deployed, and 1C is secondary, which is what we have currently, right? So if you want to check whether automatic failover is going to work, you can say reboot with failover, right? You can say reboot with failover. So when you say reboot with failover, what happens is it switches. C. C is going to become the primary, and B is going to become the standby node, and your endpoint will point to this, right? You don't have to update your endpoints anywhere. So you say reboot with failover, and you say reboot. So again, this failover will happen in a minute or 2, right, faster, but in the console it might take some time to show that it has switched. That is, here it will still show B for a couple of minutes, right? But the failover might have already happened in the background, right? With Aurora, the failover is much faster. They say it happens in less than half a minute or a minute, right? With the other DB instance, it might take a minute or two, right, depending upon how much data you have and all this stuff, right? So here, if you see, I am connected to the same endpoint, right? So let us see whether it is still online. Online means it should have failed over in the background. Maybe at the maximum, your users might have to, what do you say? Their connection might have got disconnected, but they can continue to use. So let us see what is its status. Right, it is rebooting. It's hanging. And you see it is available again. Okay. It has actually completed the failover, but still here it is showing B. Again, the console will take a couple of minutes to refresh. So here you should actually you should see C. Okay. If I go to the events and check, you see it says failover completed. Right? It took hardly a couple of minutes. But don't believe this console, right? Especially the old one. New one, I think it is updating faster, right? So let me just close this also. For some reason it started to hang. Right? So I can connect to my DB instance using the same endpoint. Right? Right? You see it is working. Right? The console is just going to take a few more minutes to update. So this is multi-AZ uh, deployment or multi-AZ failover. Okay, so it improves the availability or for DR, right? And you have to pay additional cost for this, right? You pay not only for 2 DB instances, you also pay for the multi-AZ feature itself, a small fee, right? It is not there in the free tier. Multi-AZ is not in the free tier. You can use two T2 micros, right, to do the multi-AZ replication, but that multi-AZ fee will be charged. A small multi-AZ fee will be charged. Maybe if you look at the billing, probably in the previous month, bill something. Right here you see. So here you see additional storage, right? I told you. free storage is equal to the amount of free backup storage is equal to the amount of the storage you provision. Excess you will be charged, right? So if you are doing it in a single AZ, you have a particular cost. If you are doing it in a multi AZ, there is an additional cost for that. For multi AZ, it is 2 times the cost plus a little more usually, right? It depends, right? What type of instance you are using, what DB instance and all that stuff, but it costs more than single AZ deployment. Okay? And multi AZ is not there in the free tier, right? Let us hope it is updated. This is just taking too long to update in the console, right? But technically the replication, I mean the failover has finished. Okay. Yeah. So what you can do is you can create your RDS instance, you can connect, you can explore its features, right? And maybe you want to check how uh, to restore a single database. Those type you can do, but you can't do it. What do you say? Uh, at a high level, you need to what do you say? Do it from your tools or to run a query to backup it. It is possible, right? You basically use S3 uh, to do those type of things, right? So if you are backing up a particular database, you back it up to S3, and from S3 you restore it, right? I want you to explore how to do that, right? You can't do it from the console over here. You can't say back up a particular DB because here you work with entire instances, right? If you want to back up a particular DB, right? So then you can probably execute a query which uploads this backup to S3 and same thing to restore also, right? You can create new databases. You can restore a copy of this over here for some other person to access or whatever. Those things are possible, but not over here at a high level. You need to go inside and do that yourself. Okay, so it is possible and it is done commonly also as a part of DBA activities, right? So I want you to explore that with whatever DB engine you are comfortable, right? But remember that if you are using Oracle or Oracle or Microsoft SQL Server, there are a lot of other what do you say some restrictions, right? All features might not work, like read replicas. Those things they might have some problems. There are limitations, right? So now whatever I showed you works for MySQL, Postgres, MariaDB, Aurora, those type of things. Oracle, Microsoft SQL Server also, yes, you can put, but there are some limitations, especially when it comes to read replica, those type of things, right? Because uh, those DB engines, they work in a different way. Their architecture and their stuff is different, right? So a lot of people who are using Microsoft SQL Server, they prefer Azure because it is more flexible in Azure than in AWS. It is probably only one of the services which is what do you say? It is better to host it on Azure than RDS because Microsoft they don't give all features out to everybody, right? So on their cloud platform, SQL Server hosted seems to be a little better than doing it on AWS RDS. So if you don't want to do RDS, you might very well create a EC2 instance, install your own database, and you have full control over it. So you can do your own replication, right? Logging, backups, all that you can manage in your traditional way, but in the cloud, right? Okay, so we'll just see whether this is updated. Right here, see, now it is updated, right? Now the primary is in 1C and the secondary is in 1B. It has finally shown in the console, but the change happened long ago. In 2 minutes, it switched over, right? Okay. So after you finish, make sure you delete your DB instance after practicing, right? Unless you are storing any important data, we don't need a final snapshot. We don't need to keep our automated backups, right? But any snapshots that you have taken manually, they will be there. Make sure you remove them. If you took a manual snapshot, make sure you go in and remove them. Like you saw in the beginning of the class, right? There was one old snapshot that was there. If you go to snapshots, if you see any manual snapshots, they will continue to be there. You have to go and clean them up. Otherwise, it will cost us small fee because you're storing some snapshots, right? So make sure you clean up this, or at least stop your DB instance if you want to practice the next day, because sometimes creating this takes a few minutes, especially if it's a very small instance time, right? So just make sure you clean everything up, make sure everything shows zero, especially the instance snapshots, and yeah, those are the things that actually cost you money. Okay, so please let me know if you have any questions now. Right, I hope you guys have been able to practice the other stuff also,
No, very good.
EC2 and all this stuff.
Yes, yes.
Okay, then we'll catch up next weekend, guys. Yeah,
Sure. Yeah, yeah.
yeah, thank you.